Okay, I'm recording. This is the lowest tech video ever, but I don't have my iPad. Okay, so tug of war question. This is the only way I can figure it out. So let's say it doesn't really matter how you draw it, but I'm just picking, I think it's easiest if you start with one person along any one of these axes, just to make it easier. Okay, so I'm going to say Nikki is this person. So it's 210 newtons for Nikki. And then remember, they're all separated by 120 degrees. So I'll just draw the other two off like that. So then I got this person, let's say that's Alan, I'll say. And that's at 200 Newton force. And then we got, let's just draw Janine is 190 newtons, I think, if I had that right. And we know the angles are all 120. So I'm thinking like, if this is 90 degrees, this must be 30 right here. And same with this, because they have to add up to 120, and then that's 120. So I can't figure out really how to add them together geometrically. So I think the easiest way is to break them up into their components. So what that means is you could break up each force into its X and its Y components. So like, let's check out Alan here. So there's actually a force, there's an X component force and there's a Y component force. So we can call that like Alan's X component and his Y component. So you can break up this 200 Newton force into two components. And then we're going to do that for Alan, Jeanette, and Nikki. And then how this works is you can add up all the X components and add up all the Y components. And that will be your total like resultant force. So this is another way to add vectors. So anytime you have a vector, you can actually break it into its X and its Y component, all of them, and then just add the X's and the Y's. So we put it on an XY grid. So think of this like a normal, like this is your X axis, this is your Y axis. Okay, so if we had to find these, we can use trigonometry. If you think back to like 4U and 3U, remember like the unit circle and you were like figuring out. So if we had to do that, to figure out this guy, if you think about it, it's like, let me just show you in case you totally forget. Cos of 30 degrees is equal to adjacent over hypotenuse, or x over r. So adjacent is ax and the hypotenuse is 200. And then if we were to isolate ax, we just multiply both sides by 200. So really a better way to say that is our x component is equal to 200 times cos 30. And then if you use a calculator, you'll get 173.2 newtons. So that's the X component of Alan. And then you could do that for Y as well. So if we figure out the Y component for Alan, this time we're using the opposite side instead of the adjacent. So it's going to be like the same formula, except instead of cos, we'll use sine for opposite and hypotenuse. So I'm just going to skip right to that. So it'll be 200 sine 30 degrees. Okay, here's a tricky thing. So that will actually end up being 100 newtons. But we have to make that negative 100 because it's pulling down. It's like in the negative y-axis. So Alan's is actually negative. So think about it just like on a coordinate. So Alan's has to be 100. Negative 100 newtons. But this one's positive because it's on the positive y-axis. Okay, so now that's Alan's. And you have to do that for everybody. So let's do Jeanette. So just draw a 90-degree triangle here. So right away, you know this one's going to end up being negative because it's on the negative x. And this is also going to be negative. So Jeanette's are both going to be negative forces. Okay, so if we figure out Jeanette's x component, we would get 190 cos 30, which ends up equaling negative 164.5. It's actually positive 164, but we know it has to be negative because it's on the negative x-axis. And then if we figure out Jeanette's y component, Same thing except we'll use sine. So 190 sine 30. So that ends up equaling negative 95. And again, it's negative because it's like going down on the y-axis, and this is going in the negative x-axis. Okay, so we got Jeanette's x and y components. So it's like this is Jeanette's force. It's 190 in this direction. But you can break any vector into its x and its y component, and they both add to give you this. Okay, and then Nikki's is easy. It's actually right on the y-axis. So it turns out Nikki just, sorry, I have the worst camera setup here. Nikki's y component is equal to 210 newtons. But Nikki doesn't have an x component, so we just say it's 0 newtons, because it's not going left or right. I can almost get everybody's on this shot. So that's all the components. So then to get the total, so you just add up. So the total, I'll just call that T. I'm just using any random letters. Is we take all the x's. So we got 0 plus Alan's x component is 173.2. And then Jeanette's is negative 164.5 newtons. And if we add those all up, our total x components end up being 8.7 newtons. And then if we add up all of our y components, so we got Jeanette's is negative 95. We got 210 for Nikki. And we had negative 100. So if we add all those up, we end up with 15 newtons for our y component. Okay, then we don't want an x and a y component. We want the actual resultant vector. So then what you got to do is draw this on a grid. So like just draw yourself a new xy plane. There we go. Sorry for my camera again. So if our x component is 8.7, so just do it positive 8.7 on the x-axis. And then our y component was 15, so it's positive, so we'll go up 15 newtons. And then our resultant vector would be this guy. So see how that's our x and our y. And if you wanted to add those together, you want to get our resultant, that's this guy right here. And it's just a 90-degree triangle. So we can actually just do Pythagorean theorem. So square root of 15 squared plus 8.7 squared. And if you do that math, you'll actually get, I forget, like 17.3 newtons. And that's just the magnitude of the tug of war thing. So if you want to get the actual angle, we could figure out this angle just using SOHCAHTOA. So we know that tan theta would be equal to opposite over adjacent, so 15 over 8.7. And then if we do like inverse tan of that ratio, whatever that is, that will end up equaling around 60 degrees, roughly. So that's 60. So that would make this angle 30 because they have to add up to 90. So that's why the final answer, I think, in the textbook said 17.3 newtons. And then it said a bearing of 30 degrees. So a bearing is when you're at north and you just start heading in that direction. So that's why it's a bearing of 30. So it's from north to like going in a clockwise direction. That's what a bearing is. So that's how you get that answer. That's tricky. So basically we just took each tug-of-war person, we split it into an x and a y component. We added all the x's, all the y's, turned them into their own triangle, and figured out the length of the hypotenuse, which is the magnitude of our resultant vector. Then we found the angles to get a direction. That's pretty tricky. That's the only way I could figure it out though.